Okay, so we're back. Hopefully we address some of our static issues. Hopefully. I did mess with the gain levels. I tried to bring like recording is the worst. I don't know if you've ever dealt with like audio recording or anybody has, but it is the worst. There are so many things that can go wrong. I need a lot more than coffee to calm my nerves from this crap. Okay. So our laptop went to sleep. Okay, hopefully we're better. You did some vape gear. I'm surprised you're still here. I figured you would have left. Does that legitimately sound better? Does it still sound bad? Or is it tolerable now? Because like I said, I have a Yeti, but it's not my favorite. It's a really good mic if you're gonna like hug it, but if you're doing anything else, it's kind of not ideal to have a condenser mic. Ah, thank God. That's like such a huge relief. I had planned on starting about 2.5 hours earlier today, and I got everything set up and started doing some tests, and I just like I don't know if it's the gain staging the way I had it set up or something, but like you mentioned, it's kind of like it wasn't full on static, but just some kind of like digital distortion or something that was in the line, and I couldn't like it was both mics, it was every channel in the mixer. I don't know if it's some like a grounding problem with the computer or something odd, but hopefully we got it like at least partially addressed. Because I know that does make anything really hard to tolerate when the sound's terrible. Like video quality, you can kind of tolerate being crappy, but when sound is crappy, that makes things painful. Alright, so we'll move on to our next step here. Looks like we need our medium length smooth rods. And again, it's like giving us kind of approximate measurements for where our nuts are supposed to be, but it's all in millimeters, which is kind of funny. I do have a metric ruler here somewhere, but see, this is the first thing that's going to give us some actual kind of like hard measurements here, are these rods, because these need to fit down in these little sockets. I guess they snap in? Yeah, they do snap in. Holy crap. Alright. They snap in there quite firmly. Okay. Alright, we got our base. More or less. Were you interested in buying a 3D printer, or were you just like checking things out to see how things go? Because I had watched quite a few of videos like this. Tilt that a little. I had watched quite a few videos, and my wife wondered what the hell I was doing because she didn't really know I was ordering a printer until I kind of did, and it kind of showed up. Because she wondered why the hell I was watching. Oh, did you really? I'm pretty pumped. I'm sure you have seen most of the things that I've already seen, but there are a handful of guys that review 3D printing hardware and are big parts of the 3D printing community online, and they basically have no criticism of this machine. Like, some of the criticisms the guys even acknowledged were pretty trivial, and most of them can be fixed by printing little parts and stuff to kind of address some of the issues they have. So yeah, I'm pretty pumped to start printing some stuff. That's why I was really hoping I would get to do some stuff today, but time is slowly melting away. I don't know what to do with my phone, but yeah, time is slowly melting away. Is that clock correct? Is it 1:15? Let me double check. Oh, we have quite a bit of time left. I'm just hoping to get the bulk of the structure. But I guess if you ordered yesterday, you're having to deal with some of the production delays. I was a little bit frustrated because I ordered the day before they updated the site, and put that there's like a short delay on shipping the kits. So mine was a little bit delayed, and I wasn't expecting it to be, but they're pretty good. I don't know if you saw their site. They actually have one of those systems where you can get directly on their site and chat with customer support, and they respond really quickly. Yeah, it worried me. I think there are a lot of good kind of knockoff kits out there, but some of the issues that people had, it kind of worried me, and I don't want to be spending the first couple weeks of owning a printer dealing with a bunch of stupid issues and trying to like fix a bunch of things and tweak everything. Like it seems like most people that got this kit actually just kind of assemble it and start printing stuff. You know, you might need a little bit of tweaking to square your y-axis stuff up and stuff, but for the most part, seems pretty sweet. I'm gonna see if I can find this roller here. Again, I have one with that's all metric. I just do not know. It's not something I use that often. That's great. I managed to find it quickly, but uh, half of the markings are kind of worn off of it, so these will be approximate values at best. Okay, so it's telling us we want these roughly 100 millimeters from the face of this orange piece. So we'll get them right close to that. That's pretty close. Like I said, the advice that some of the guys that have already assembled the kit gave was to not worry too much. Like, you obviously want to have these approximately where they're supposed to go, but not to waste too much time really trying to fine-tune it until you get all the components into place. So apparently next we need our bed here. And I'm not sure what we're supposed to be looking at here. Apparently we're supposed to have a white dot, but I do not have a white dot on mine. Interesting. I don't know if that was a production oversight because they've been kind of swamped with orders. Kind of like, I don't know if you saw the beginning, but mine didn't actually ship with the instruction manual, even though it was marked off the parts list. Yeah, oh, okay, I take that back. This does have a countersunk hole right there. Okay. So the bearings get laid on the opposite side, from what I understand. One of the ball... When placing the bearings onto the Y carriage, make sure that they are oriented as shown in the picture. One of the... Okay. I think I see what they're saying. If you look inside these bearings, I don't think this is going to translate on the camera very well. But if you look inside, there's actually 4 lines of bearings on each axis running the length of it. And from what I understand, they want you to make sure that one of those lines of balls is down. Like, if you can imagine this bearing sitting there, you're going to have a pair of ball bearings that are, or lines that are going up and down, and then a pair that are like this. And I guess that's so that when this is, the weight is actually, like if you can picture this flipped over and weight pushing down on it, you want to make sure that the bearings are pushing on the rod and not something else in there, like not the plastic bushing. And we'll double check. It was tough for me to see at first. In the corner here, there is a slight indentation. There you can kind of see it. Like, let me get it there. We have our hole that's drilled the whole way through, and then on one corner, on one side, there is a little machined indent here. And from what I understand, that's supposed to be down when we're placing our bearings, and they'll actually go on the top. And I wish this translated a little better. They do have a decent photo in the manual here, but we want to make sure that our lines of bearings are down against the plate, and they're not oriented in some odd way. So that looks okay, I would say. Let's double check. Okay, so that's sitting there. And I would assume these other two are the ones we need. I would assume they're the same. I don't know why one of them was loose and these two are in a nice greased package, but maybe I'll put the two greased ones together. And this other one up on the front. Okay, so it looks like they just set in these little troughs there. We'll put it here for the sake of assembly. And we'll line our bearings up so that they're balls down, if you will. Alright, and our indent is on the bottom currently. And it looks like we just go ahead and fish these tie straps through the little holes. I believe we're doing this correctly. Like so. So we'll go down through and then back up through. And these will actually hold our bearings into place. I know it kind of freaked some people out that tie straps are used for some of the structural components here, but it apparently is not an issue. And I'll double before I close these up, I'll double check some of these pictures. Oh, I see they did it differently. They fed the tie straps through the other way. So we want, I don't know if you can see that, the kind of knot on the bearing, or the tie strap, should be on the bottom. And then we'll come up through and down over top the bearing. Kind of the opposite way I did it the first time. And again, we'll come up through and then over top the bearing and then back down through the plate. And do the same thing with this third one. They don't really mention the orientation of the other one, so maybe it doesn't really matter. But we'll do it so it kind of mirrors the other two. We'll come up through and then back down through. And we'll make sure our line of bearings, it's something that's pretty obvious when you're looking at them. When you look inside, there's lines of bearings, and we want to make sure they're absolutely down so that the whole weight of this carriage is pushing on the balls. Generally don't want a lot of weight on your balls, but this is an exception. So we'll kind of snug those up, and we're supposed to use our needle nose pliers to really tighten these down then. So we'll just kind of get them started and snugged, and then we'll flip this over. Double check. See, I did bump those, so make sure you double check your orientation before you tighten these down. Because you want this, it's really important that this carriage moves as smoothly as possible. But beyond that, it does feel like, even with these snug, it does feel like they're gripping quite well. What's up, man? Oh, see, I wish that had went over there a little better. Now I moved that tie strap. I'm going to have to reorient that bearing. But they all look good. This looks good. This is going together quite nicely. So we're going to take our needle nose pliers here. And I would imagine you don't have to make these insanely tight. Because after a certain point, you're gonna actually break the tie strap. These will take a good bit of force, but they're not going to take anything crazy. It's about as tight as I think I can get them. A couple clicks. No, those are in there quite tightly. I wouldn't have any concerns about the ball bearings. Really? Oh, I'd say that, and then I was able to shift that one. Let me see if I can snug them up a little bit more. Like I said, I don't want to get crazy with it. Because it's tough too, but you can break these little tie straps. Depending on how strong your hands are. That seems pretty good. All right. So, double checking in our picture, we look just like the photograph there. We have our tie straps laying flat, and there's our little indent on the top with the bearings on the bottom. So, next step. Oh, see, I should have done that. I should shift them over. I'll see if I can. If you orient the tie straps right, they come up. There we go. The tie strap will come right up through the hole and go through the locking mechanism of the strap. So I think I will be able to get those a little tighter if I do it like they're suggesting. Their initial picture didn't really have them oriented like that. But I see in this final close-up they do have them. I don't know if you can see on our secondary camera here. I know it's kind of difficult to see, but this is the head of the tie strap, and then it goes down through the plate and comes straight back up. And if you orient them like that, the tightener on the strap is actually flush with the plate, which I think will let us get them a little tighter. And then we're going to go back and reorient the line of bearings so that it's at kind of 90 degrees to the plate. And now I should be able to tighten these down a little bit more. Oh yeah, I got 2 more clicks out of that one. I got 3 out of that one. So that does make a difference. I didn't break it. I did pull the end off the tie strap, but it didn't actually break. I think I'll leave that one. I'll quit while I'm ahead. Yeah, we'll quit while we're ahead. Okay. And then we'll again double check the orientation. And they seem to be pretty good. This one moved a tiny little bit. There we go. Some of this stuff, I don't know how critical it is. I would imagine it does matter. But you were going to stop over? You can if you want. I didn't want to have anything running on the computer while I'm streaming because I'm afraid. Some of this stuff's already finicky enough. But yeah, if you want to stop by, just like not come in the carport door. You can come right down. I think you're going to be surprised when you walk in here. There's a lot of shit set up because I had to move my computer over and everything. I wish this laptop would be good enough for streaming on, but it is not. It is terrible. Okay, so our next step here. We need 2 of our M3 12 screws. Which, again, our 1-to-1 chart on our bags here is pretty handy because if you tell me to grab an M3 12 screw, I don't know what the F you're talking about. I guess that's it. Because there's an M310 and an M312 screw in here, and they are almost identical. Like, the one probably has like 4 more threads on it. So I think I got the right ones. Yeah. Okay, so we need these 2, and I don't think these holes are threaded. So these must actually go into the part itself. So that's our little orange piece here. And we have our bed laying like so, with our part oriented thusly. And is there nuts in there? Okay, there are little lock washers in there. So this doesn't thread into the part itself. It just goes down through the bed. Maybe it does thread into the bed. It's kind of a snug fit. I don't think these are threaded. I think it's just kind of a snug fit through the metal. I could be wrong. We'll flip it over and check the other side. So I would imagine these won't tighten up. Maybe they will. I don't know. I guess we're going to find out here in a couple turns. I don't know. That kind of snugged up, but at the same time it is sticking through the other side, so I'm pretty sure we're supposed to put a washer on there. Oh, it even notes, here I am talking like an idiot, there's no thread in Y carriage. Just push the screws all the way in. Okay. This part isn't quite as perfect as some of the other parts. It looks on the inside here we have a little Z-axis wobble. But again, I doubt it matters. Okay. Step 16. We're going to put the 8mm smooth rods. Which ones? I assume they're these ones. Maybe we shouldn't have snapped them in. They might have said that. Let's scroll past. Yeah, I don't think we were supposed to snap these in. Okay, so we're going to have to pop those back out. Which, yeah, that's a good fit. Ooh! Mama. Sorry if that's loud. Okay. So we're back here to step 16. So we're going to thread these rods through our bearings. Which I could imagine those making noise. Like some of the noise that 3D printers make, I would imagine are these linear bearings. Because they fit okay, but at the same time, I could imagine them translating a little bit of vibration through the machine. Alright, so we have those in step 16. Okay, step 17. We need to install the bearing. So we have our longest screw here in the pack. We have a single nut and a pair of washers. So it looks like you can orient this any way. I don't think this little aluminum piece has to be oriented any particular way. But we do... Huh. I don't know if the bearings are supposed to go on the inside or outside. Or the washers, I'm sorry. They show the washers being on the outside against like the plastic. So the washer will go on the screw. And then the screw will go through the hole. Again, a little bit of a snug fit. I don't want to have to screw that the whole way through. I guess we'll do what we have to do. See if I can push it through. That's a little too snug to push through. So we'll just screw it through. Yeah, and then it looks like the washer is, again, on the outside on the other side. And this is just the... There's no teeth on this. This is just a bearing and a little wheel for the belt to ride on. And I assume the motor and whatnot will mount on the other side. So we'll put our other washer on after we drop it. Because that has a little bit of walk. I guess that's kind of necessary to make sure it doesn't bind if your belt's a little bit off. And then it just instructs us to use that and our little Allen wrench to tighten these up. Which I think is easier said than done, given that we can't make a full rotation. I think it might be easier to move the pliers. That is a tiny little nut. I don't know if they comment on how tight this needs to be. I would imagine that okay, when tightening the screw, turn just half a turn max after the washers touch the 3D printed part. So once you actually get this to the point where it's tight, you don't want to over tighten it. I would imagine that this will squeeze the plastic into the little bearing thing, so we don't want to do that. So I would say there we're just tightened against the plastic. This will go like another, there's a quarter turn and about another quarter turn. All right. Spins nicely, has a nice little bearing on it. Okay. And we don't want to lose our other screws, so we'll throw them back in our package. And we'll make sure these are the rest of the way in. It's funny they said the plate isn't threaded, but these are actually tightening up rather snugly. Like, there is room for a nut to go on the other side there, but I can't imagine that you'd actually need it. That's a fairly tight fit. Okay, step 18 is complete. Step 19, we need to attach the Y-axis motor. And like we showed at the beginning of the video, these motors are all screen printed. This is the Y-axis, correct? Yes. You can see these are all very nicely screen printed. This says right on there, this is the Y-axis motor, so there will be no confusion there. Let me grab a paper towel. We'll wipe the little bit of what I assume is like manufacturing lubricant off of there. Off the face, not the drive arm. And looks like we have our motor sitting like this. Oh, we are on the other side here. This is a heavy little assembly. We have our wires coming out towards us underneath. Well, it looks like we're actually going to end up coming through these two rods. So I'll push those wires through here. I hope to God we've done everything correct at this point, 'cause we're getting to the point where if we haven't, we have quite a bit of disassembly to do to fix it. So we have that, and then we need M3 10 screws. So these will be the shorter ones here. Two little hex head screws. And you can double check them on here, but yeah, these are the correct screws. And it looks like these just go through the plastic part and actually thread into the motor itself. I assume he uses the same hex wrench here. Yes, sir. Alright, so they thread in nicely. And then we'll go ahead, we'll set this assembly to the side for now. And get our other screws in here. It's kind of floppy without it all tightened. And this one you kind of have to inchworm in because you can't get a full rotation on your Allen wrench. But I have to say, so far, this is going together rather easily. There's a few things that are a little vague in the instructions, but nothing that would actually concern me. Alright, and we're just going to snug these up. We're not going to make it too tight. We don't want to crush our plastic piece. And we certainly don't want to destroy any threads. Alright, that feels like it's not securely mounted in general, but it's securely mounted to the plastic piece that it mounts to. Okay. And if you can see there, in the picture, it actually has the wires going down under our threaded rod, but it seems to fit most naturally just coming out between them. So we might have to address that later. Or adjust that later, but I guess we should do it like they say, because they do have the wires coming down underneath of that. So I'll thread this back through. If it makes more sense later, we can always switch it back when we're doing our cable routing. But it's probably best to do what the highly educated engineer that designed this suggests that we do. Because I am a bit of an idiot. So we'll take his word for it. Or hers. Or hers. I don't know who designed this. Well, I'm pretty sure Joseph Prusa did, so we'll take his word for it. Okay, the next part is a little switch. Which I do not see. That must be in another bag, I assume? It looks like we have a little micro switch that is our end stop sensor. Because we have our cable there. But that was all of the parts in our step 2 bag. So I don't know if that's in one of these bags. We do have end stop micro switches in here, but this is not the box that we're actually working on. So it looks like they do have the ability to add comments here. So there's 2 comments here. We'll see what they say. step were we on? This is step number 20. So we'll see what the comments say about step 20. Yeah, I don't know. We'll double check our other parts. I don't want to use these if I'm not supposed to, but these are two little micro switch end stop detectors. I mean, it looks like exactly the part we need, but it just concerns me that these aren't... Okay, okay. This box does have multiple numbers on it. It has 2, 3, 4, 5. So I assume this is the part we need. And it doesn't differentiate between the two, so I assume the leads are all the same length. We'll double check. They're kind of tangled. Yes, the leads, I don't know if you can see that. The leads are the same length, so these are the same. So we'll just take one of them, kind of coil the other one up, and tuck it back in the box. Okay. So this little guy, if you can see the switch, the actual switch is off-centered. And it looks like it goes towards the motor, like the switch is closer to the motor. So it has to orient this way. And I assume the bed comes back and actually pushes against that. Gene, I did plan on finishing tonight, but I had some audio issues that I actually just addressed when someone pointed out that it still sounded terrible. And it actually took me 2.5 hours to get the sound sorted out. So I wanted initially to finish tonight, but I actually have to leave at about 4:45 to pick my daughter up. And I probably won't be able to stream anymore tonight. So we'll be starting first thing in the morning tomorrow and finishing everything up. And then more than likely, we'll spend the whole day doing test prints and calibration and stuff and just kind of enjoying this thing. And yes, this is absolutely my first printer. I have no experience with 3D printing at all. Like, all I did was kind of browsed YouTube for a few months and tried to learn as much as I could from guys that had done videos. And from all the research I had done, this is a fantastic machine. And we had talked earlier, this is more expensive than basically any other i3 kit on the market, because these are all part of the RepRap project. Like, this is all actually open source design. But this machine is made by the guy who actually designed or helped design the initial i3 design of printers. This is straight from Joseph Prusa and his little company. So this is one of the highest, if not the highest quality i3 printer you can buy. And I'll more than likely I'll link to some of the reviews, because there are some guys who are experienced 3D printers and do product reviews and all that kind of stuff. And all of them have just absolutely glowing reviews of this printer. If you look, there are quite a few. I mean, essentially all of the other i3 kits are cheaper than this one, but you definitely get what you pay for. As long as I do a relatively decent job of assembling this, barring any unfortunate events, we should be able to print relatively high quality prints right from the get-go. And you don't really have that with some of the other kits. No, they don't, Gene, and that is a huge feature. This printer will actually check, I believe it's 6 points, it might be 4, but I believe it'll automatically check 6 different places on the print bed and level itself. And it's not some weird like software well, I guess it is ultimately software leveling, but yeah, that is not a feature that you can get on any other printer kit. And it removes a whole universe of headaches that you can have with getting your plate properly aligned to your, what would that be? I guess your Z-axis. I could be wrong. Like I said, I know almost nothing about this stuff. Oh, I know. I actively searched for several weeks to find someone who had something bad to say about this printer. And they're just, I mean, the only things that you'll see is if something got damaged in shipping or someone assembled something improperly. Because there are a couple things you can do if you kind of botch the assembly and then you do your first prints. You can do some odd things, like you can run the extruder head into your print bed, and that can like damage the coating on it. But still, even something like that's relatively trivial, especially since they give you an extra sheet and everything. So no, like I said, I don't personally have any experience, but absolutely everything I've read has said that this is worth the extra money you pay. Which to me, I don't want to spend the first few weeks I own this machine just fiddling with it to try to get it to perform properly. So for me to spend an extra, I don't know. Like I said, I have the invoice there. Finished to my door, it was $770 US. And that is pushing double. I mean, that is double what some of the other kits on the market cost. But I don't want to have to deal with the problems that some of those people have dealt with. I have enough technology in my life already that causes me problems. Like these freaking mics and the soundboard and all that stuff. You see, I had to move the soundboard over there. I think that was part of the problem. It was too close to my computer. But I don't want to be dealing with that with my printer. I have enough technological issues in my life. I don't need to be trying to coax good results out of my printer too. Okay, so we have this attached. I guess that's tight enough. It's kind of hard to judge how tight these are since they're going into the plastic itself. So they feel kind of tight the whole time. And I don't want to strip these out or over tighten it and crush the micro switch or anything crazy. So that feels secure. Like my grandfather used to say, it's good enough for government work. If it needs adjusted, we'll tend to that later. Okay, so now we're actually going to attach this carriage assembly. So we'll orient it like they have it in the picture. I wish I had the manual because it'd be easier to let you guys see all of this stuff. I think we don't need this right now. So we can set this out of the way. They have it oriented like this with the motor to the right. Wires kind of... They have them nicely out of the shot. They don't have them dangling wildly in their way. And then we want to have the 2 linear bearings away from us. And then everything else looks right. We have our bearing here. We have our motor assembly here. And our black piece is over here. So looks like we're doing things properly. Sorry if that's loud. These do snap in pretty hard. Because I think these get... Yeah, there's little... I won't put them on right now, but there's little slots here where tie straps go through and hold these down. And I've seen people voice some concerns about, you know, I don't want tie straps holding my printer together. But I think the snaps alone are sufficient for holding this into place. That is a pretty good fit. And you can hear the bearings make some noise, so I would imagine that's going to make some noise. But it does move fairly easily. I mean, it takes very little effort to push that aluminum plate, so... there's that step. Seems like we're correctly oriented. We have our screws poking through like they show in their picture. So we are on to step 23. And sure enough, that's the next step, is putting our tie straps on. And they have them going over top and then down under. I wouldn't imagine that matters too much. But if you orient these the right way, it allows less slack in them because you don't have the tensioner part kind of at a weird angle. So I will do it like they have it, just because there's no reason not to. And we'll do these, we'll just mirror them so they look like somebody who cared assembled this. Because I think this kit I think is $699 US. And I think for $899 US, you can buy an assembled one, which does give you some peace of mind because they test everything. They assemble it and then run some tests. But, again, like, I think it was Gene had said, I think multiple people have said, I have yet to see any bad reviews of this printer, like, kit, assembled or otherwise, so I'm not really concerned about it. I definitely don't think it's going to be an issue. Okay, so we're going to tighten our zip ties here. And again, I think I did do it the opposite of how they did it. Hopefully that's not an issue. They are kind of hitting the thing. I think I'll move those around just to the I don't know what you'd call that, the tightener. The catch on them is as flush with the bed as possible. Worst comes to worst, I can cut them later. This is a really common item. You can buy a bag of these for probably $2 to $5 at a place like Lowe's or an electrical supply place. So we'll go ahead and tighten these down. Worst case scenario, we take them off later and replace them and orient them the correct way. But for now, I don't foresee it being a problem. Because I don't actually know how far this travels. I mean, I don't see it being an issue. They don't touch when they're oriented this way. All right, again, you don't have to like He-Man tighten these, because the bar snapping into the plastic is holding it mechanically. So it hasn't mentioned cutting any of these yet. Okay, it did kind of orient them a little differently. But I don't think that's a problem. The next thing we need are 2 M3 nuts. Though I don't actually think I'm gonna put them on, because this notes in this step, we're on step 24. These are optional because it says in chapter 7 these nuts will be removed, and this is already holding, like I mentioned earlier, that's in there snugly, so I'm not even going to do step 24. So we'll go ahead and skip that. Step 25, now we're actually going to, well, I was going to say we never actually put the drive gear on our motor, so what it's going to have us do now is put the belt into the tensioner, which they actually have the tensioner out as a single piece, and mine is now securely fastened to my carriage, so I guess I'm going to have to do this upside down. So we have our belt here. That's a nice little belt. Doesn't have any stretch in it, which is nice. Okay, so we're going to have to orient this properly in my mind here. So they have the part laying like that, and with the teeth down, this goes in, up, and over the peg inside, and then the teeth actually lock back together to keep it in place. So this will probably be interesting on the first try. And I know, sorry, you don't have an angle on this. And I want to not use as much excess as possible. So we'll work it down in there and then snug it up. And that doesn't look like that would hold that all that well, but that is actually a really good mechanical hold on that with it kind of pinching. I'll try to get the camera on it here. If you can see it in there, down in this block here, the belt loops over itself, and then the belt's teeth actually lock itself into place, so that's not going anywhere. So that's a good little mechanical hold there that has on it. And that is all of step 26. So it actually has us leave this. I won't jump the gun. Like, obviously we have to thread this around that bearing and stuff, but the next step is actually to fasten this little drive wheel onto our motor. And I don't know if you can see this here. Here's our motor. I don't know what the best way to orient that is. There's our motor. And it'll be oriented like this. The thick part will go towards the motor. And the shaft, feels like the shaft has one flat spot. So we'll make sure that one of our, it says don't tighten it yet. So we won't do that yet. It just says to slide it on. So we'll go ahead and slide that on there. It looks like we're going to have to loosen our set screws a little bit with our tiny wrench. So we'll just back those out a hair so we can slide it over the shaft. So we're on there. And then step 28 has us just feeding the belt through. So we're going to keep our belt flat, and the teeth of the belt will actually go against this wheel. So we'll go underneath and come up through. So there's that part. We just go under and up through with the teeth facing the wheel. Okay, so now we have to... That's odd. Now we have to loosen the motor. So we're supposed to loosen the top screw, with this upside down, the top screw. For some reason. It's kind of odd. Could have had us just not tighten it in the first place. But whatever, they probably have a reason for doing it that way. So step 29 is just to loosen that. Oh, okay, we're supposed to remove it. We're not supposed to just loosen it. Because we need the motor to rotate. So we're going to completely remove this. Use our handy little needle nose pliers. Going to remove that screw, and then we actually rotate the motor until it hits the ground. So we're actually like rotating it counterclockwise away from where it was fastened. And then it actually doesn't show this, but it's obvious what they want you to do. So they want us to loosen the motor and then feed our belt over top of it. And that's going to let us, when we put this back into place, that's going to put the required tension on the belt. So it's understandable what they want us to do here. So we're going to basically do the same thing we did before. We're going to fold the belt over itself and have it lock itself with its own teeth again. Which I can tell already, this one's going to be a little bit more awkward. I'm going to put one of these wrenches under each corner, which will allow me to rotate the motor just a hair more. Give us a little more belt to work with. And we're going to go in and just kind of guesstimate where this is going to loop over. And then I think the easiest thing to do would be, once you've done that, kind of see approximately where the teeth are going to lock together, and then lock them, and now slide it into the assembly. It seems like that's probably the easiest way to do this, because it's kind of awkward to get it in one piece at a time. And I'm trying to be careful. I don't want to damage any of these teeth. Okay, and I think we've got it in there. I'm going to actually use, it doesn't really say that. Okay, it has us using the needle nose pliers to kind of seat that back in. I don't want to do that. I'm going to use the screwdriver. And we're just going to kind of push that back on the spool a little bit at a time, so it seats the whole way down in this slot. Maybe I do have to do it the way they're doing it. Because that is a snug fit in there. There is no room to work in here. Like, I see the angle they've got it from, but I don't know how they're getting in there at that angle. I can't really get it with this bar in the way. We're just going to kind of walk that back until it's flush with the other belt. I guess you'll kind of, some of this stuff, it'll become obvious once you get to the step. You'll just have to do whatever it takes to get it where it's obviously supposed to be. But that seems like it's more or less lined up with the other one, and I guess we'll go ahead and pull that out so it's doesn't have any slack on it. And then hopefully that's enough tension. I don't know if it will be or not. I think we could probably get another tooth out of that. I don't know. I'm going to go ahead. I'm going to pull that back out and try to get it a little bit tighter. My intuition is telling me that's what I should do. So I'll keep it where it is. And we'll just shift the teeth one more to try to get... that would probably only be, I don't know, not a significant amount. Maybe a couple millimeters more. Shorter. And again, we'll try to snug it up in there. And then we'll put the motor approximately where it's supposed to be. I don't know. I'm just trying to think how hard this would be to do later. I don't think it would be too bad. Even once we're completely assembled, I think if we take this bolt out again, we can just repeat this process. Like if we needed to take another tooth or two out of the length of the belt, I think that will be doable later. So we'll just leave this as is. That might be snug enough. I don't know. We might end up adding a little bit of length when we square all this up. I'm not sure. I really don't know how tight that should be. I don't really know. So we'll leave it. I won't waste too much time on that. So we'll get our screw back in our motor. We'll rock it back into place. And get our set screw back in there. Or a mounting screw. This isn't a set screw. And knowing that we might have to adjust this later, I'm not going to make this super tight. I'm just going to snug it up. Just snug. I mean, I guess that's taut. I wouldn't say it's tight. Well, see there it's saying that it should be quite tight. I guess we'll do it. I'll try to get another tooth or two out of that belt. There's no reason not to try to do it the right way. So we'll rock the motor again. We'll pull it out of the block, which it is coming in and out a little easier now, so it's not that big of a deal. And we'll actually go 2 teeth. We'll shift where it's interlocking by 2 teeth and slide it back in. Yeah, now that we've freed that plastic up a little bit, it is quite a bit easier. I think it still holds plenty tight, but it's a little easier to slide the belt in and out to adjust the tension. And we'll snug it up over the loop. A little bit of pressure, and now we'll put our screw back in. And we do have a little bit of twang, like they're saying we should have, so that's good. I would imagine, because these are just threaded rods, I would imagine you wouldn't want to have it tight to the point where you're bowing those. But who knows? Maybe you should. Like I said, I don't know a whole lot about 3D printers, so this will probably be obvious to someone who has a little more experience. These Allen wrenches are kind of a pain in confined spaces because you can't get full rotations on the wrench. But there, we got it. And this is definitely not straight. I guess we should take a moment here because these are still not tightened down. So both the motor and the end wheel there can be shifted. So I'll do my best to line it up, because if you look at these three pieces, get it in the camera here. This piece is stationary. This is not going to be adjusted side to side, but both of these pieces can be. So if you get like a top-down view here, you can see whether the belt lines up with itself. And like anything that works like this, the straighter you can get it, the more smoothly it's going to run. And that looks fairly straight there. So we'll kind of snug these up. That looks like that would run fairly true. So we'll kind of snug all this up. Just finger tight. We're not doing anything crazy yet. I'm still hesitant to like commit to making anything super tight. Yeah, like I said, Gene, I ordered, like no joke, a day. It was 24 hours before they actually updated. It was the 27th. That's right. Because apparently the 28th was some international holiday that I wasn't aware of as like an American. Maybe I should have been. I don't know. It wasn't a holiday I was familiar with. But so they were off the 28th. And then I guess when they came back is when they updated the site to say that there was like a 3 to 5 day lead time on the kits because they were like frantically printing parts. So yeah, I had to wait a little bit longer than I was anticipating. Because they had it marked that there was, I think there's like a 3 to 5 week lead time on the assembled machines. Because I imagine they do take quite a bit more time. And I think we're pretty good. I can see that will need a little bit more adjustment as far as like keeping the belt running true. Because we still haven't tightened our drive wheel, so that's part of it, because that's still like able to drift a little bit. So that was 32 was rotating the motor back and tightening it. And now step 33 is adjusting the Y slider. Which I guess step 33 and 34, doing what I just said I was doing, is just kind of like eyeballing the belt to make sure it looks like it's running true for the most part. Which I think it does. I think that looks okay. I don't think that's going to walk all over the place as it's operating, so that doesn't look bad. And then 34... Yeah, 35, I'm sorry. 35 is actually tightening the drive collar on the motor. And they do mention this. If you look at the drive shaft on the motor, it has a flat spot on it. And what you want to do... I don't know how easy it's going to be for me to get to that. They should have mentioned that earlier. You're going to want to take that flat spot on the drive shaft and orient it in a way that you're going to be able to get to a set screw that's on it. Because I actually lucked out, and the flat spot on my drive shaft is facing me right now. It's directly up. So again, we're just going to eyeball this, make sure our belts are straight coming in and out of this block. It looks acceptable. I don't know that it's perfect, but it looks acceptable. And then there are 2 set screws on the drive pulley, and you're going to want to orient one so that that set screw is going to push flat on the flat part of the shaft. Which, like I said, I kind of lucked out. It's kind of dumb luck that it lined up like that. And we're just going to kind of snug that down. Nothing crazy. You don't want to strip any of this stuff. Kind of put you in a bad position. And then I would assume you're just going to want to tighten the other one up too so it doesn't work its way out. And just kind of snug them up. And then I'm just going to hold this. And it looks like our belt's running pretty true. It's not walking back and forth on the pulleys or anything crazy. It looks like this pulley could be oriented a little bit more this way. So we'll go ahead and wiggle that over. Loosen our screws up. So that looks good. And I think our motor, I know I already adjusted that, but I think our motor could go a hair this way. Let's kind of wiggle that over. Which is not easy to do now that we've tightened the belt. That does have a good bit of tension on it. Just going to want to kind of be careful. And we'll just snug that up good with our fingers. We can tighten all this later. All right. So that is the end of step 35. Step 36 just has us doing some cable management. So we have this flipped over. And I would assume some of this should be tightened by now. I know we've been kind of deferring the tightening, but I think they have a lot of this stuff snugged up already. So I hope we didn't wait too long. Kind of put ourselves in a bad position. Because I'll tighten all these up pretty good. I mean, it does push a little bit harder because we are attached to our stepper motor. The quad material option, this is a personal thing for me because I tend to buy more stuff than I need. And I have a habit of getting, like my camera, you can't see it right now. We do a podcast and stuff. We do a video podcast with a couple friends I have. I have a habit of buying, like I save up and I buy some of the nicer equipment available. And my purchases kind of outpace my ability to utilize that level of equipment. And for that reason alone, I'm not going to be getting the quad material option, the multicolor printing or whatever you want to consider it. For no other reason than that I want to have a good bit of experience under my belt before I make a jump like that, because there's a significant amount of stuff you can do with a printer like this without that. And I want to get to the point where I've kind of exhausted a lot of that stuff before I make a jump like that, because I think if I buy it too soon, being that I'm like a complete amateur at 3D printing, I don't want to get it and then not really utilize it for everything that it offers, because it does give you quite a bit of power when you're printing stuff. I haven't done a lot of research, but like I would imagine it allows you to have your materials for like support and stuff. Like I know there's some support materials that dissolve in water, which make removing it quite a bit easier. So I would imagine you can do things like that where you have multiple colors plus like a different type of PLA or something for your support material. And I just don't know enough about 3D printing really to utilize that, so in the long run, yes, I will be getting that, but for the foreseeable future, no. Uh, and I would imagine if I did, I would probably get the I think they have a 2. I could be wrong. I think they have a 2 and a 4, or maybe it's a 3 and a 4. But I'd probably get the smaller of the 2 upgrades first. Again, just so I allow my experience to keep pace with my purchases, which I tend to not do, and it's kind of, you can get yourself in some positions where your expectations are outpacing like your actual ability to deliver some of that stuff. So yeah, I'm gonna be waiting. Okay, so now it has this, I guess, flattening the y-axis, and I actually have. Again, I'm just gonna throw these on the floor. We'll tend to that later. I actually have something that I use. I do miniature wargaming and a couple other things. And all this is a giant glass cutting board. And one side has like a texture and one side is smooth. And this has been invaluable over the years for leveling things. To have a nice, relatively true... I mean, this probably isn't perfectly flat, but it's pretty damn close. So this all seems to be fairly level. So we will start snugging up some of these nuts. Not super tight, but I think we are getting to the point. Get on there, wrench. There we go. We are getting to the point where we do need to start committing a little bit with some of these. That is a tight fit. I mean, that seems to be pushing okay. I don't know if it's like has resistance because we're out of square, or just because it's finally hooked to the stepper motor. So we're not making that insanely tight, but I wouldn't be surprised if we're not square. We don't seem to have the same amount of thread sticking out, so we'll kind of just eyeball it for now. Loosen that front one and tighten the back one. Because this is, I'm hoping this isn't going to be something that haunts me later. Like how kind of fast and loose I was with squaring the bed up. Again, we're not going super tight, but we will snug that down. Because this does seem to sit nice and flat. I don't know, I would assume it's going to become evident pretty quickly whenever we do some prints, whether or not our bed's square or not. So I think the machine will let us know if we screwed something up. And luckily, none of this is affixed permanently. So if we do need to come back and adjust something, I don't think it's going to be the end of the world. Huh. That guy in there is kind of tough to get to. Alright. Just kind of snug them up. And I guess we'll go ahead and snug some of these lateral axes up as well. Oh, see, now that we tighten that, we do have a little bit of wobble. And it recommends to just flex it, because I guess everything does give a little bit. So we'll just flex it a little bit. And there we're as flat as we could be. Alright, going the wrong way. Just kind of snug it up. Not super tight. Nothing crazy. We'll just get these a little more than finger tight. I think it's time to do a little more than finger tight. Some of these are easier to get to than others. But I like the design of this. It is fairly forgiving. Like I said, it's not like we're welding this frame together so that if we do something wrong, we're just screwed. So we seem to be sitting flat, so... Get a wrench in there. And just snug them up nice. I guess ultimately we could, I'll probably have to pick a better roller up than this. This is one that I've had forever, and the metric lines are kind of worn off. So I might pick up a little cleaner roller at some point, and we'll actually take some measurements of some of this stuff, because we should be able to get it pretty close by doing that. And then we can just like manually adjust each one of these corners to try to get it as square as possible. We'll have to flex that out again. I'll go ahead and finish tightening these. I think we got that one. Snug this guy up. These wrenches, the chrome, between the wrenches being chromed and the nuts being kind of coated, that's a tight fit on there. I think that one's tight, and I think we got this one also. Yeah, that's good enough. All right, so we did introduce a little bit of flex in there. Ooh, went the wrong way. There we go. Perfectly flat. And I guess that seems to still operate pretty smooth, so I think we're within reason with being square. So if we have a problem later, we'll just deal with that when the time comes. Okay, so that was step 37, to level our axis. And I guess I do have a square here. We can kind of eyeball this to see if anything's like grossly misaligned. I mean, just eyeballing it, that looks pretty close, all things considered. Let's get that roughly aligned. I mean, I would never say that's perfect, but that's pretty close. If it's close enough, I guess we'll find out soon, or find out pretty quickly when we start to print something. Okay, so step 38. Secure the axis feet. Oh, that's what those little foam things were. I see. I guess they just help dampen vibration a little bit. There's 4 little felt feet with self-adhesive on them, and they go on the bottom of these pieces right here. Nice touch. I don't know if this is a recent addition, because if you go in Thingiverse, there's actually some little isolation or dampener isolation feet. They're little 2-piece prints, and you print them out yourself, and they just kind of like make the bed float. Or well, the whole machine, not just the bed, but the whole machine kind of floats on them, so it doesn't translate quite as much vibration into whatever surface the printer's sitting on. because one of the very few complaints I've seen in a review of this machine was that it's kind of noisy on high power mode, and that basically eliminates that problem. So again, one of the few pieces of criticism that people had, and it's eliminated by printing yourself a solution. You can't really beat that. All right. So now we've got nice feet. Everything seems to operate properly. Make sure our zip ties are snugged up. Make sure I got all these. Yep, they seem good. Okay. That was step 38. Step 39, we're all done. Woo! One thing we will do that they didn't really, I think, tell us to do at any point was, there are some side cutters on here, but I have these little end cutters, and we will trim the zip tie leads. So we'll just go ahead and snip all those off. All right. So are those, and then we have the ones on our bearings here. You don't want to cut these too short. You want to leave a little bit of material on there so that the tooth can still catch on the zip tie. If you cut them too short, you can actually undo the mechanical grip that it has on the teeth. Okay. I guess we should tighten these up. We'll address our belt alignment here again, now that we are kind of complete. Because we do sort of have to fix this. I can see now that we tightened everything up that this isn't running as true as I would like it. I guess the first step is going to be to make sure that inside the block you have your belts lined up with each other as much as possible. Like, make sure they're seated completely back in the block. Because if they're not lined up there, you're going to have a hell of a time lining it up anywhere else. And you just have to do whatever you have to do to walk that back into the back of the block. Just use a little bit of one of these Allen wrenches. And a little bit of force. And we don't quite have it there. We got it. We almost have it. Because if it's coming out of there crooked, you're never going to get it aligned. And then we'll loosen these up so they're completely out of the way. Because this needs to go over this way a bit. And if I hold the belt over itself, it looks like this pulley is lined up adequately, I would say. And then our motor needs to go a couple threads over this way. So we'll loosen this up. And I doubt now that this is under tension that we'll be able to just move that itself. So we'll actually use the nuts on the other side to walk it over. And we need to go a good bit yet. I don't know how that was so out of alignment. All right, a little bit more. I wouldn't say it's hard to line this up, but it's a little tough to get it all. Since there's so many pieces that can be adjusted, it's the curse of freedom. When you have the ability to adjust things, it tends to like overwhelm you with options. Just trying to eye that up. That looks pretty good, I'd say. Maybe this needs to go a hair that way now. So we'll kind of tighten those up. And we'll tighten the motor back up. Nothing crazy. We don't want to crush these plastic parts. Man, those wrenches are tight. I think I have a file here. I had a file here. I don't know where it's at. Maybe I can scratch a little bit of this chrome off with a knife. That is a tight fit. File obviously would have been the better option, but I think I got a little bit of it there. Okay, so now we're going to tighten this bottom part. I don't think that really helped all that much. Oh well. And if you do have this centered, you're going to kind of want to rotate both nuts at the same time, because if you don't, you're going to end up walking it one way or the other, as one nut tightens more than the other one does. So you're going to want to go opposite directions at the same time. Alright, that's pretty tight. That's pretty tight and pretty straight. Again, I don't think that's perfect, but that's pretty good. I don't think that's going to cause us any problems. If you can see, I'll try to hold that there. If you can see, that seems to go pretty true. The belt seems to be fairly well aligned. That's all we're looking for. Seems to be fairly tight. I think we're good to go. And the one step that we did kind of skip was there was a little bit of cable management here where they zip tied this cable along there. But I'm going to wait until we're done to figure out what we want to do as far as like cabling solutions. So that is all of that part. And it's approximately 2:30. What is our next part? This was part 2 and like step 40, I think that was. Part 2, step 39. Okay, so that's the end of part 2. And it looks like part 3 is the X-axis assembly. I'm actually going to take a break here for probably less than 15 minutes. I'm going to grab a little bit of food to eat, take a bathroom break, wash my hands because I do have quite a bit of residue from all these machined parts. And we'll come back, and step 3, or part 3, is assembling the X-axis. So we'll do that when we come back. We'll be back in less than 15.